Hello students, welcome to another session of the Bridge course. In today's sessions, I'm going to explain an important concept called logarithm. To understand this concept, let me start with an example. I'm going to consider a number 1000. Can we write this as a 10 into 10 into 10? Which is same as 10 to the power 3. The 3 is called exponent or is also called power, and this 10 is called the base. So 1000 is equal to 10 to the power 3. Now the same number we can write in one more format, which is logarithm. And this logarithm, in short, we write log, L-O-G. Logarithmic of 1000 to the base 10 is equal to 3. Therefore, that power is called logarithmic of this number to the base 10. So let me write one more number. It's 100, which we write it as 10 into 10, which is 10 to the power 2. So how to write this in logarithmic format? Logarithmic of log of 100 to the base 10 is equal to power, which is 2. Clear? How about 1, which you can write as a 10 to the power 0. Not only 10 to the power 0, I can write any number to the power 0 is always 1. How to write this in log format? Log of 1 to the base 10 is equal to 0. And what you get to notice here in all these three numbers are the base is always 10. So is it mandatory to write logarithm in terms of the base 10? No. We can write any number to any base value. So for that, I'm going to give example. Let me write 32, which is 2 to the power 5. Am I right? So log of 32 to the base 2 is equal to 5. So what you get to notice here, I have written logarithmic of a number with a different base. But the kind of log that we are using is with the base 10, and such logarithm is called common logarithm. So that's why most of the numbers which we are using in our calculation is a number with the base 10. So that's why I've given more example for the base 10. So hope you have understood how to write the exponent form in terms of the logarithmic format. So now I want to find log of a number. Log 2 to the base 10 is how much? Let that number be y. So let me write this in exponent form. 10 to the power y. 10 to the power y is equal to 2. So what power of 10 will give a value 2? Can it be equal to 1? No, because 10 to the power 1 is not equal to 2. Can it be half? Y is equal half. 10 to the power half. What is 10 to the power half? 10 to the power half is a root. It's a root 10, and root 10 is definitely not equal to 2. Because it's only root 4 is equal to 2. So root 10 is not equal to 2. So what is the value of y? The value of y that we get is 0.3010. That means 10 to the power 0.3010 will give you a value 2. Now you may wonder how I got that value. And this kind of values for any number is given in a table called logarithmic table, which you can see on your screen. For any number, if you want to find the log, here there is a table which we have to use it to find log of any number. Now, this particular table was invented by John Napier, and he even invented Napier's own. It's a kind of manual calculator. The kind of calculator which we have now is electronic. We call it digital calculator, but it's a manual calculator which he has invented, and he is even given a credit for using the decimal point in mathematics. So John Napier invented this entire table, and which we are using it even today to find the log of any number. Where do we use this logarithm? We use this logarithm to find the intensity of sound. So you must have heard the two units, bell and decibel. So to find the intensity of the sound, we use this log scale, and the value is expressed in terms of the bell or decibel. It's even used to find the brightness of the stars, to find the magnitude of the earthquake. So what is the scale which is used to find the magnitude of the earthquake? It's a Richter scale. So Richter scale is measured in terms of the logarithmic scale. Greater the value, greater is the magnitude of the earthquake, and greater is the damage caused by this intense earthquake. It is also used in chemistry to find the pH value. It is also used in statistics. So these are the applications of the logarithm. And now let me give an example as how to find logarithm of any number, even the fractional number as well. Okay. So please see the table. I'm going to give an example, and then I'll tell you the method by which one can find the logarithm. So first I want to find the log of 12.56 to the base 10. So when you find the log of a number, this log of a number has always two parts. One is characteristic. The other part is called mantissa. The first part is characteristic, the other is mantissa. How to find the characteristic? Just by observing the number and by analyzing, you can find the characteristic. How to find the mantissa? You have to make use of this log table, or it is also called as the Clark's table. Now, how to find the characteristic? To find the characteristic, see the number and see where the decimal point is. Just before the decimal point, count how many digits are there. How many digits? So in this number, there are 2 digits. So a characteristic is always one lesser than the number of digits before the decimal point. So number of digits before the decimal point is 2, 1 less. That means it is 1. So 1 is the characteristic of 12.56. That's the characteristic. And mantissa is always a fraction. So that means I have to write a decimal point. Now to find the mantissa, split the given number into 3 parts. How many? 3 parts. So the first part should contain 2 digits. The second part should contain 1 digit. And the third part should contain 1 digit. So that's the rule. So whatever the given number, split into 3 parts. 2 digits, 1 digit and 1 digit. The number is here 12. And from the Clark's table, in the first column, you will find that number which is here 12. Then The next single digit is 5. And that you have to find in the first row, which is here, 5. And now you see where this 12 and 5 intersect. They intersect at this number. And that number is 0969, which I'm going to write here, 0969. The fourth digit is a 6. And that you have to search in the last column under the heading called mean difference. Can you see that on your screen? Mean difference. So the number is 6, which is here. And now in the same row, you see where they intersect. And it will intersect at the number 21. 21. So you add that 21 to the previous digit. So on adding, here I'm going to get 10. This is 9909. So this is that fraction, and write that here, 0.0990. So 1.0990 is the logarithmic of 12.56 to the base 10. I hope you have understood. I'll give you more example to make things clear. So I'm going to write the number. Logarithmic of 1.256. You can see the digits are the same, only decimal point is shifted. How to find the characteristic? Before the decimal point, there is only one digit. So characteristic is always 1 lesser than that. How much? It's 0. Correct? 1 lesser than the number of digits before the decimal point. Before the decimal, there is only one digit, not one number, one digit, correct? 1 lesser than that, correct? 1 minus 1 is 0. That's the characteristic. Mantissa is always, it's a fraction, that's why you have to write the decimal. Now, as I mentioned earlier, split the given number into 3 parts. 2 digit, 1 and 1. 2 digit, 1 and 1. Irrespective of the position of the decimal point, split into 3 parts. Correct? That is 12, 5, 6. Now, even here, it was a 12, 5, 6 only. So, don't you think the mantissa has to be same as this number? See, 12, 5, 6, 12, 5, 6. 12, 5 here and 6 in the mean difference. So I'm going to get the same mantissa, only difference is the characteristic changes. So therefore the mantissa is 0990. So let me write one more number, log 125.6. Again I have given the same number. I mean the digits are identical, only decimal point is in some other place, right? So first let's find a characteristic. Decimal figure here. How many digits are there before the decimal? 3. 1 less. How much? 2. So 2 is the characteristic. How about the mantissa? 12, 5, 6. Isn't it same as the previous? So the mantissa has to be same, 0990. So this is how we can find the log of a number. So I'm going to give a slightly different number so that we can find a different mantissa, okay? Right. So how about log 15? I want to find the log of a number 15. Can we write this 15 as 15.00? It's one the same, right? First let's write the mantissa. Decimal point, 2 digits before the decimal figure. 1 lesser than the number of digits before the decimal, so it's 1. So 1 is the characteristic. How to find the mantissa? Split the given number into 3 parts. First 2 digit, always it has to be first 2 digits only, okay? 2 digit, 1 and 1, which is 15, 0, 0. Let's see the table. 15 is here, 0 is here, and 15, 0 intersect at a number 1761. 1761. And there's no 0 under mean difference. That means This itself is the mantissa, so it's 1761. So this is how we can find the log of a number. Okay, so characteristic and the mantissa part. Fine. Now I would like to give a log of another set of number, that is log of a number which is lesser than 1. What you get to notice here is all the numbers that I have written is a log of a number which is greater than 1. So I am going to write now log of a number which is lesser than 1, for which the rule is slightly different. Okay, slightly different. So okay, so I'm going to start with a number, log of a number which is lesser than 1. Okay, 0.09236. So when the number is lesser than 1, what is the rule? How to find the characteristic? The rule is like this. Here, take the decimal figure, and after the decimal figure, listen carefully, after the decimal figure, how many zeros are there? Immediate zeros. So that you need to consider. Okay, tell me here immediately after the decimal point, how many zeros are there? There is only 1 0. And now here you have to increase it by 1. 1 0. So plus 1, that means there are 2. Correct? So you have to consider 2 as the characteristic. So what is the rule? Take the decimal point, and after the decimal, okay, after, not before, after the decimal. Before there will be only 1 0 always. After the decimal, you count the immediate zeros. Correct? How many zeros are there? Increase it by 1. So there is 1 0 plus 1 means a 2. Right. Now, whenever the number is lesser than 1, this characteristic is always a negative. So that's why we represent it by drawing a line above, and we read this as a 2 bar or bar 2. Okay. Then we need to find the mantissa. The rule is the same. Split the given non-zero digit, non-zero, not the 0 digit, non-zero digit into 3 parts: 2 digit, 1 digit and 1. 2 digit, 1 and 1. So it is a 9236. 92 in the first column, 3 in the first row where they intersect at a number 9653. 9653. The fourth digit is a 6, which have to refer from the mean difference, which is here 6. And where 92 in the same row intersect, it intersects at the digit 3. That 3 is to be added at the end, not at the beginning, at the end, and that will give you 9656. So therefore, write this together, and now logarithmic of a number 0.09236 is always a bar 2, 9656. So characteristic of a number greater than 1 is always positive, whereas the characteristic of a number which is lesser than 1 is always negative. So one more number to make things clear. Log 0.00096. Okay, so this is the number. So let's find the characteristic first. How do we do that? First, see where the decimal point, and after that, see how many digits are there. 1, 2, 3. 3 zeros. Increase it by 1. So that makes it 4 bar. How do you find the characteristic when the number is greater than 1? Count the number of digits before the decimal point and subtract it by 1. Correct? If there are 2 digits, characteristic is 1. If there are 4 digits, characteristic is 3. But whenever the number is lesser than 1, count the number of zeros and raise it by 1. Hope there is no confusion regarding this. Okay? Right. So how about mantissa? Take the 0 digit, which is 96. What about next? It has to be 0 only, right? 1 digit. And one more digit again, it has to be 0, correct? Because that given non-zero digit, we have to always split into 3 parts. 2 digit, 1 digit, and again another digit, okay? Right. So 96, 0. Where is it? Here it is. 96, 0 will intersect at 9823. So we have to find 9823. So this is the logarithmic of 0.000960, which is 4 bar 9823. Now what if the number contains more than 4 digits? If it contains more than 4 digits, then we have to use the rounding off rules. Hope you are aware of it. For example, if it is 10.56 and if I have to round this to only 3 digits, then we have to raise the previous digit by 1 and it becomes 10.6. There are certain rules are there which I am going to explain later. So we have to use the rounding of rules if a number contains more than 4 digits. Okay. So I have explained how to find the logarithmic of two numbers, one number greater than 1 and the other number lesser than 1. So this is the method of finding the log of two numbers.